Welcome to the fifth video of the second chapter. In this video we are going to cover probability sampling. So what probability sampling is all about? Let's get started. Sampling is actually a way of selecting items from a given population. The very rule that tells you how you are going to select your items or members from a group of people, how you are going to, what is the rule that you are going, is it some kind of random or is it some kind of, is it at the call of researcher or is it happening by chance? Let's say something which is happening by the researcher's choice, so that will bring in a lot of things to address, like choosing or not choosing someone, or choosing someone doesn't gives a fair chance for everyone to be included. So that's why random sampling is where you talk about sampling that utilizes some form of random selection. So and it is not a new thing, we all are practicing it, random selection, from a very long time. We all know, we all have played this game where, let's say 5-10 of our friends, they put their names into a hat and someone simply tries to pick one of them. So there is a fair chance for everyone to be selected, or for, let's say, a given act. So this is what a typical example of random selection. So nowadays we tend to use, we have computers, we have different functions we can use to generate random numbers, and we could use those numbers as a basis for random selection. So the simplest form of random sampling is simple random sampling. And how do we define it? As like, if every element of a given population has a known and equal chance of getting selected, has a known and equal chance of being selected, then we call it as a random sampling. For those of you who have background in mathematics, you must know, you must be aware of NCN. You have combination and permutation. So basically combination tells you that in how many ways you can select small n items from, let's say, a total of n items. So that is called NCN. So once this NCN has an equal chance for every element, then we call it as simple random sampling. So we could use simple random number generator table, or we could use software or mechanical device to select sample using simple random sampling method. Let's say we have list of clients. Let's say a company has 1,000 number, let's say 1,000 clients, and you wish to know what is the satisfaction level of the clients. So you randomly select 100 clients out of these 1,000. So you could very well use a random number generator, or you could simply, this is your sampling frame, this is the comprehensive list. So from that sampling frame, you have the names here on, let's say you open an Excel sheet and you have all the names on one of the column. The column adjacent to it, you could generate random numbers using some kind of function, right? You have this RAND, and you could use some kind of number to generate numbers, random numbers. So you could generate random numbers, and you could further arrange this random number in ascending order. So based on your random selection, you could very well select 100 items out of this 1000 clients. Okay, so this takes just less than a minute, just a matter of few seconds if you have everything on Excel. So yes, simple random sampling is easy to accomplish and explain it to others. That's its advantage number one. It's easy and easy to understand, easy to explain it to others, and definitely it provides it is quite reasonable to generalize the results, because there is no biasness or the choice of the researcher which is at play. It is purely due to chance. So chance factor is there, so that is why you say there is no biasness or preferences at work. But at the same point of time, I must tell you that it may not be the most statistically efficient method of sampling, because at times you have some better ways of selecting things. So what are those? For example, let's say we have another random sampling which is called stratified random sampling, and this is also called quota random sampling, and it involves dividing your population into homogeneous subgroups and then taking a simple random sampling in each subgroup. So what you do, you first of all divide the population into non-overlapping groups, what we call it as strata. Let's say your population has people belonging to different age groups. So you have children, you have adolescent, you have adults, youngsters, mid-age and elderly, and you want to have a representation of this group. So right from child to the elderly, you want everyone to be part of the sample. So what you do, you actually create such strata. You put people, all children in one box, all elderly in one category, and this is how you do it, right? So you have different ways of depending upon how many, it is very likely that you won't have equal number of members in each strata. Some strata will have more members, some will have lesser members, but the point is that the strata should be non-overlapping. And then you calculate this small f, which is small n upon capital N in each strata, and this is what you do to select people. Why is it important? Why stratified random sampling matters, especially when you deal with when your population has small minority groups. So it so happens that if there are let's say 85% of people are of, let's say, or the majority are of type A, and there are, let's say, 15% of people belonging to type B category. So if you are to randomly select people, there are more chances of selecting only this one and lesser chances of here. So that is why it so happens that you may have underrepresentation, problem of underrepresentation. In order to check that, you could very well create stratified random sampling, where you say that let's talk about two strata, A and B, and then let's try to fix some kind of quota. I have to select 100 people, so not less than 50 from A, not less than 50 from B. So this actually matters, because otherwise these 15% would not be able to voice their concerns. But this is how you could make at least make allowance for that. Yes, they are very much included in the study, and they could present their views. You could have their opinions. So accordingly, because you are using different let's say f value. For if it is same for every strata, you say that it is proportionate stratified random sampling, whereas if that is not the case, you are using different sampling fractions, then it is called disproportionate stratified random sampling. So as through in terms of a picture, as you could see, this is from the US, and you have three set of people: Caucasians, African Americans, and Hispanic Americans. So these, each one of them actually represent a strata. So if you want to conduct a study, let's say select 100 people out of them, and you fix that criteria, not less than 25 from each. So you could do that, 25 from here, and then you could arrive at this score. Okay, so that is the beauty of stratified random sampling, that you could still make out the opinions, views of minority. That is also part of it. So from stratified random sampling, we next move to systematic random sampling, and it is again about determining randomly where you want to start, and once you have started, you just take up this, like every xth element, every ith element we want to select in the framing, in the sampling frame. So you do some kind of ordering, 1 2 3 4 ascending order, and then you decide on the sample size. Let's say capital N is the population size, and you want to extract, let's say small n number is what you want to extract. You calculate small k as capital N divided by small n. So this will give you interval size. Kth element, randomly select an integer between 1 and k, whatever that value would be. Let's say it is 20, then from any number from 1 to 20 you should select. You take that first number and then you go on kth number afterwards. This is very much this becomes easy to grasp in this example. As you could see, let's say we have a list of 100 people, and we are to select, let's say 20 people out of them using systematic random sampling. So we calculate this k value by dividing capital N from small n. So 100 divided by 20 is 5, so our value of k is 5. So now we select a random integer from 1 to k, let's say 4. So first one would be 4, and then we will keep adding this k value. So k plus 4, 4 plus 5 is 9. So as you could see, 9 for 4, then 9, okay, then 14, then 19, 24, and so on. So as you move, so this is something which is an example of systematic random sampling. Every sampling what we have learned till now has some kind of application or situation in which they are more appropriate. For example, systematic random sampling could be very useful when you want to select, let's say if you are to visit a library and randomly select, let's say a library has 100,000 books. So even to stratify it, you would be very, very difficult for you, for anyone to actually see. Let's say 1000 books if you have to select, then it would be little difficult for you from where 1000 books. If you do stratified, it would be very tedious. So what you could do alternatively is, where the book catalog is there, you could use some kind of systematic random sampling. Like, let's say you try to divide this thing, small n by capital N, you arrive at some number and you select a number integer from 1 to, let's say, 1000. In the same example, let's say that number is 257. So you first select that 257th item in the book catalog, and then you also try to just measure it using a scale, that after how much of the length you have, what is the gap between 1000 books, let's say, catalog. So you said you figured it out that it is come somewhere around 2.75 inches. So this is what you have to move. So what you could do is you could use very well the compass. You must be aware, in your school days we all have used it. So you could use that 2.675 and you could very well make such, you put it here and then from 257 you add it, you keep doing this 2.75. After every 2.75 distance you arrive at that number. So let's say 257 plus 1000 is 1257, and again 1000 is 2257, and this is how it will move. So you just have to move 2.75 inches and another 2.75 into 2, 2.75 into 3, and so on and so forth. So you could select that way. So this is just an example to give you a systematic random sampling, how this works. The next one is the cluster or area random sampling. When you have to sample a population that is dispersed across a wide geographic region, we consider doing cluster sampling, where we divide our population into different clusters, usually along geographical boundaries, and then we randomly sample clusters. The final step is to measure all units within sampled clusters. So what we do is this. Let's say we are to do this, we have to interview the administrative persons of the New York state. So instead of going to every possible counties, there are different counties, extensive traveling is involved. So what we did, we used cluster or random sampling, where we randomly chose, let's say, 5 counties, 1, 2, 3, 4 and 5, and there we took our interviews. So instead of covering all these areas, we just covered these 5 areas randomly, and we try to make an inference out of it for the whole New York state. So in order to assess the efficiency, administrative efficiency of official, we could do that. So cluster or random sampling work that way. In real scenario, in most of the applied social research, you may not be using just one of these 4 methods. You may be using a combination of them. So depending upon your sampling needs, you could combine 1, 2 or more of these things, or all of these, what is normally called multi-stage sampling. So maybe in the previous example, you could choose first you could choose the clusters, and then if the population within each cluster is more, then is much more to cover, then you could again use, let's say, systematic random sampling. So you are using cluster and systematic in the same study. So that is a typical example of multi-stage sampling. So that is all in this video. We'll discuss about non-probability sampling in our next video. Keep watching. Thank you.